Hello friends, welcome to Biochem. Today I am going to talking about the classification of alcohols. So please guys subscribe my channel and also like or share with your friends. Okay, now let's start classification of alcohols. So before classification of alcohol, first introduction, what are alcohols? What are alcohols? So alcohols are hydroxy derivative of aliphatic hydrocarbon which are obtained by replacing one or more hydrogen atom of aliphatic hydrocarbon with corresponding number of hydroxyl OH group. Alcohols are represented by general formula ROH, where this OH is hydroxyl group. Hydroxyl group. This act as what? As a functional group. Functional group. Now this R is alkyl group. Alkyl group. Or substituted alkyl group. Substituted alkyl group. Okay. Now, alcohols may also regarded as alkyl derivative of water. I will give the example. This alcohol is also regarded as the alkyl derivative of alcohol. So now, for example, suppose we can obtain the alcohol, suppose hydrocarbon RH here, treating with the air. Suppose removing of this hydrogen atom and by adding here OH group, hydroxyl group, then we get the ROH. This is the alcohol. Okay. Now, in case of water, here H and OH, and removing of hydrogen atom and by adding here alkyl group R, then we get the ROH. Here again the alcohol, but this alcohol is what? Alkyl derivative. We get the alcohol from the water. This is the water. This is what? Hydrocarbon. Now this is the alkyl derivative of water. This alcohol, alkyl derivative of this alcohol is what? Alkyl derivative of water. This. So this way we can define what are alcohols. Okay, now classification of alcohol. So we can classify the alcohols by different ways. Okay, different ways we can classify. So sometimes we can classify depending on the OH group present in the compound, number of OH group present in the alcohol. Sometimes one OH group, sometimes two, sometimes three, sometimes more than three. Then this way we can classify the alcohol. Another way, on the basis of the nature of the carbon atom. So what type of carbon? OH bonded with the what type of carbon? This OH has a functional group bonding with the what carbon in the compound? Sometime first degree, sometimes second degree, sometimes 3 degree, third degree. So 3 degree means primary, secondary and tertiary alcohol. Okay, so in two different ways of classification of alcohol. So okay, now classification of alcohol. So alcohol can be classified by different ways, two different ways at first. On the basis of number of hydroxyl group, OH group present in the alcohol, first one. Now second one, here be on the basis of nature of carbon atom, means three different types of carbon atom present in the organic compound. First degree, second degree, third degree, primary, secondary and tertiary, bonded with the OH group. In the case of alcohol, OH present in the compound, then you can say compounds are alcohol class of compounds. So two different. Okay, now classification of alcohol on the basis of number of OH group, number of hydroxyl group present in the alcohol. So alcohol can be classified 4 different ways: monohydric alcohol, dihydric alcohol, trihydric alcohol, or polyhydric alcohol. Means mono means 1, di means 2, tri means 3, or poly means more than 3. If more than 3 OH group present in the compound, then polyhydric. More than 1, dihydric. More than 2, trihydric. Only 1 OH group present, then monohydric alcohol. So for example, ROH. So ROH, R is the alkyl group, OH is the functional group. So if R is equal to CH3, then OH. So this alcohol is the methanol. Okay, methanol. Okay. Now if R is equal to ethyl group, CH3, CH2, and OH. So this is the ethanol. If R is equal to this alkyl group, R is equal to propyl group, then CH3, CH2, and OH. So this is the propanol. So propane 1-ol or 1-propanol also you can write. So this is the monohydric, only 1 OH. These are the only one OH group. 1 OH group present in the alcohol, means in the compound hydrocarbon, then we can say the monohydric alcohols. Okay, so this way we can write the name of the compound also. Now dihydric alcohol means here 2 OH group present in the compound. Dihydric means 2 OH. Okay, so 2 OH means, suppose your compound is, for example, CH2OH. Okay, again CH2OH. So here the name is what? 2 carbon here. So eth is a word root, eth plus ane, ethane, and 1 position here, 1 position, and here 2 position. So 1, 2 diol. So in the IUPAC name you will study. So ethane 1, 2 diol. Suppose your compound is CH2OH, CHOH, here the CH3. Then compound, what is the IUPAC name? Here 1, 2, 3, 3 carbon. So propane 1 position, 2 position, 1, 2 diol. Okay. So here number of OH group, how many? 1, 2. Here again 1 and 2. 2 hydroxyl group present in the compound, in the alcohol. Then alcohols are said to be dihydric alcohols. Okay. Now trihydric alcohol. So tri means more than 2 OH group, more than 2. Then we can say the trihydric alcohol. For example, CH2OH, CH2OH, CHOH, CH2OH. Okay, so this is the 3 carbon here and 3 OH group. So prop is the word root, prop, and ANE, propane, 1, 2, 3 triol. Okay, triol. This propane triol. This is also known as the glycerol. Glycerol or glycerin. Glycerin. Okay, so these are the example of the trihydric alcohols. Again here trihydric alcohol, another example. Suppose your compound like this, CH3, CH, and again here CH2. So here OH, then OH, here the OH. OH, and OS. So number of carbon here 4. So but is the word root, but plus ANE, and position of the OS 1, 2, 3 triol. So these are what? This glycerol, propane 1, 2, 3 triol, butane 1, 2, 3 triol. These are the trihydric alcohol. Both are trihydric alcohol. So this way. Now remaining polyhydric alcohol. So polyhydric alcohol means more than 3 OH group present in the alcohol. A polyhydric alcohol Polyhydric alcohols. The alcohols having more than 3, having more than 3 OH, hydroxyl group present, okay, in the alcohol. More than 3 OH hydroxyl group present in the alcohol, then we can say the polyhydric alcohol. So, okay, for example, CH3, CH, and now CH2. Then bonding with the OH as a function group, OH, and now OH. So more than 3, here the 4 OH group present in the compound. So total number of carbon we have to numbering 1, 2, 3, 4, and 5. So paint is the word paint, and plus ANE, and position of this OH how many times? 1, 2, 3, and 4, and 4 times. So tetrol. So A replace, so tetrol. Okay. Pentane 1, 2, 3, 4, and tetrol is the name of the compound. Okay. If more than 4 times present, if number of OH 5 times present, then what is the compound? CH3, CH, OH, CH, OH, CH, OH, CH, OH, and CH2, OH. So total number of carbon 5, 1, 2, 3, 4, 5, and 6. So hex is the word root, hex plus ANE, hexane, 1, 2, 3, 4, 5, comma, dash. How many times? 5 times. So pent and plus ol, pentol. Okay. This way we can write the name of compound. Now in next example, the polyhydric alcohol like this, CH2, OH, CH, OH in bracket here 4, then CH2, OH. So this compound you can write like this, CH2, OH, CHOH, CHOH, again CHOH, CHOH, and CH2, OH. Both are same. Okay. So then your total number of OH is 6. 6 times hydroxyl group present in the compound. Then we have to write the name. To total number of carbon 1, 2, 3, 4, 5, 6. 6 carbon present means what would is hex, and carbon single bond A and E, hexane. Now dash how many times? 1, 2, 3, 4, 5, 6 dash. Hex is the what? Hex means 6 times present. Okay, 1, 2 times present, di, 3 times, tri, 4 times, tetra, 5 times, penta, and 6 times hex. And then ol is the functional group, secondary suffix, ol can be written. So hexane 1, 2, 3, 4, 5, 6, hexol. This is the name of the compound. At the common name sorbitol. Sorbitol is the common name. Okay guys, in this way we can classify the classification of alcohol on the basis of number of hydroxyl group present in the compound. So first one is the monohydric, second is the dihydric, then trihydric, and then polyhydric. So more than 3 OH group present in the compound is a polyhydric alcohol. So thanks for watching this video.